In this demo, we will review Fortinet's CTNA solution coming in 7.0. In the current security setup, everyone in the corporate network is considered trusted, and anyone connecting remotely has strict security policies in place. This approach for security is no longer valid, as users and applications no longer reside in one place. Users can be connecting from anywhere in the world, and applications could be hosted in data center or cloud. For remote workers to access protected resources, they need to connect VPN. And when resources are distributed in various locations with multiple VPNs, then it gets further complicated, affecting the user experience. With CTNA, users can access resources from anywhere with full security and a simple user experience, irrespective of the location. They could be on corporate network or connecting from a coffee shop. The per application access is granted after device verification, after user verification, and context-based posture check. Only after all these requirements are met, the access is granted. Fortinet's CTNA solution leverages core fabric devices that you already have in your environment. So let's see how it actually works. First, when an endpoint connects to the EMS, it's onboarded, which means it's licensed and then it's provisioned. As part of the provisioning, all this endpoint telemetry is then sent to EMS. So the device information, OS information, network information, logged in user information, the security posture information, any vulnerabilities, any AV software installed, and domain that the device is connected to, all that telemetry information is then sent to EMS. EMS then can have ZTNA tag rules configured, which uses this posture information to tag endpoints and share those tags with FortiGate. So when an endpoint initiates a connection for a resource, FortiGate can use those tags to do posture information, do the identity information, do the identity verification with single sign-on and multi-factor authentication using Forti tokens, certificates, maybe SAML with IDP, and if the authentication is verified, then the access for the resource is granted. So these basic steps already exist in 6.4. In 7.0 with the ZTNA, we are further improving the user experience so that no matter where the user is located, the experience is the same. So as part of the 7.0 enhancements, EMS will have its own ZTNA CA certificate that will be shared with FortiGate. And as part of the onboarding, the endpoints will be assigned a device certificate. So when endpoints initiate the traffic to access a protected resources, that EMS signed certificate is used to verify the device identity. And based on that, the posture information is also verified. So with that, anytime an endpoint tries to access the resources, the traffic is proxied to the gateway where the posture information is checked, the device information checked, the user identity information is checked. And if all the verification is successful, then only access to that resource is granted. It's a per session access, and every time a new session is initiated or any time a new request is sent, the whole check happens again. In this topology, we basically have endpoints connecting over the internet to a FortiGate, which acts as an access proxy. The FortiGate is connected to EMS for posture information. It also is connected to AD server for SAML IDP for authentication. And behind the FortiGate, we have our protected resources. These are on the private networks. We have a web server for testing, and then we have a Windows server for RDP demo. First, we will check the EMS setup for onboarding managed endpoints. EMS server is the central intelligence for endpoint information. It receives real-time telemetry from endpoints that is used for security posture check for trust verification and access control. Make sure the EMS has ZTNA license and a valid ZTNA CA certificate configured. Also, EMS should be connect it to your FortiGate in the fabric so it can share endpoint telemetry and posture information. Next, we will connect FortiClient endpoints to EMS to make sure they are centrally managed and get provisioned. We will enter EMS IP address or FKDN to connect it to EMS server, and endpoint should receive the profile. On EMS, you can then configure the posture rules. Like in our demo, we will use rules to make sure endpoint AV is enabled and up to date. You can also configure additional rules like vulnerability status or corporate device check. On FortiOS, make sure you have EMS connector connected and status is up. This will help EMS share posture information via FortiGate. Next, we will also configure the ZTNA server. This is the RDP and HTTPS servers that we want remote users to access. We will also create a ZTNA policy so that we can do security scanning on the traffic accessing our secure server. Back on EMS, you can see all connected endpoints and their telemetry plus security information. You can also see all the ZTNA tags for each endpoint. First, we will be doing HTTPS proxy demo. In this demo, FortiGate is acting as a proxy server for ZTNA, and we have enabled posture check so only endpoints that have AV software running and up to date is allowed to access our web server. For this endpoint, it has AV software enabled. With this, the endpoint, we will try to access our test web server. Browser will send our traffic to our proxy server, which will prompt us for SAML authentication. After authenticating, we will be able to access our web server as endpoint meets the posture criteria. Any endpoint from anywhere in the world can access a protected web server without requiring a VPN. Now let's turn off our AV on endpoint so it's no longer compliant. Now when the same endpoint tries to access the web server, the access is denied by proxy gateway. Next, we will demo the device ownership check. In this demo, we will demonstrate the device ownership check functionality where, for additional security, you can enforce that only device owners can use the corporate machine to access your protected resources. If you have EMS server connected to your AD, then it will automatically retrieve the device ownership information and use it for posture check. You can also specify the ownership information manually. For our demo, the owner is set to user 3, but we will try to access our web server while authenticating as user 1. So in this use case, the device belongs to user 3, but user 1 is trying to use it to access our protected resources. The posture check in this case will fail, and access for that user will be blocked. Now let's change the owner to user 1 and try to access the website again. This time we will authenticate as user 1 and posture check succeeds and access is granted. The last use case we will demo is for TCP forwarding. So if you have other than web-based resources that user must access, then you can use TCP forwarding. In this demo, we will get remote user to RDP into our protected web server. Again, no VPN is required and traffic will be proxied via ZTNA gateway. First, open FortiClient and add a ZTNA rule to forward traffic for RDP server to ZTNA gateway. Then open RDP application and enter RDP server address to connect. User will be prompted for SAML authentication. Once authenticated, the access to RDP server will be allowed. Again, no VPN tunnel required with ZTNA agent. The traffic is end-to-end encrypted and proxied via ZTNA gateway to the protected resources. Thank you for watching.